y'all. This is Guided Practice 19 on section 5.1 and 5.2. We're talking maxes and mins. So what we're going to do here is we're going to be asked to classify all extrema. And what that means, extrema just means your extreme values. So you're looking to find and classify all your maxes and mins. Okay, so you have the choice here to use either the first derivative test or the second derivative test. I'll try to use both here. And that way you get some experience with both. Typically, my rule of thumb is if I can easily take the second derivative, I'm going to use the second derivative test. If I can't easily take the second derivative, then I'm going to stick with first derivative test. But that's my rule of thumb. You can use whichever you'd like. First derivative test will always work. Second derivative test will most of the time work. Okay, but if it fails, then you got to fall back. Okay. Regardless of which of the tests we use, our first step is always the same. You're always going to find your critical points first. So in order to find a critical point, I'm going to take the derivative. So in this case, 2x minus 6. And we're going to set that equal to 0. So to find my critical point, I'm setting that equal to 0. Now there's no fraction here, so that it's not going to be undefined anywhere. So I don't have to worry about it making it undefined. If I go ahead and solve this, I can add 6 and divide by 2, or I can just factor out the 2. And then set what's in parentheses equal to 0. And that's going to give me x equals 3 as my critical point. From there, then we get to choose first or second derivative test. So on this one, I would absolutely go second derivative test. And the reason for that is that the second derivative is easy to calculate. So if I take the second derivative, the second derivative test is going to be 2. And I don't have any x's to plug anything into. This is always greater than 0. It's always positive. And we know that when the second derivative is positive, that means our function is concave up. And so my critical point then must be the local max right there at the bottom. Okay, and so we would say there's a local max at x equals 3. Now, if we wanted the y value or the point there, we could go ahead and plug our 3 back into the original, and we could figure out what that's going to be. It'd be 9 minus 18 plus 7, so you're looking at 16 there. So 3 comma 16 is your max point, okay? But that's an example of the second derivative test. Whenever I have easy polynomials, I'm always going to take the second derivative, plug in my critical point, and determine whether it's a local max or a local min, okay? All right, number 2, I'll do this one using first derivative test just for some variety. Actually, yeah, that's fine. Okay, so regardless, again, of what I'm doing, I'm going to find my critical points first. So I always need the derivative first. If you're not starting out by taking the derivative, you should always take a derivative. Okay, from here, we're finding the critical point. So we're setting this equal to 0. And I'm going to go ahead and factor it right away. So let's see, I need 2 numbers that multiply to negative 32, but add to negative 4. That's going to be a negative 8 and a positive 4. And so that's going to give me x equals 8 and x equals negative 4. Okay, so now if I'm going with first derivative test, I'm going to be testing in the first derivative, which means I'm going to need the domain, which my domain here, this is a polynomial, so I'm going all real numbers, negative infinity to positive infinity, and I'm going to break it up at negative 4 and positive 8. So I think about it kind of like a number line. And then I'm going to go from negative infinity all the way up to negative 4, then from negative 4 to 8, and then from 8 to infinity. Okay. Now from here, I'm going to choose test points. I want a test point in each interval. So in this interval, I'm going to choose negative 5. In between negative 4 and 8, I'm going with 0. And a number bigger than 8 would be, let's go with 9 or 10, your choice. And I'm going to be plugging that into the first derivative because we're doing the first derivative test. And my first derivative is this one right here. You could also use the factored form if you like, which is this part. I didn't do any algebra besides factoring it, so I could use the same one there. If I plug in negative 5, that's going to give me 25 plus 20 minus 32, and that looks to be positive. So my derivative is positive, and that means that the original function is then increasing. Okay. At 0, if I plug 0 in, I get a negative 32. And so on the function then is decreasing. And if we plug in 9, you get 81 minus 36 minus 32. That's going to be positive. And again, I don't really care what the number is. I just care whether it's positive or negative. And then if I'm going up and then down, the -4 must be a local max at the top of the peak. And if I'm going down and then up, then this one must be a local min down at the bottom. And then to summarize, I want to say that I have a local max at x equals -4 and a local min at x equals 8. Okay, and that's one's using the first derivative test. And again, I probably wouldn't with this particular function because the second derivative is easy to calculate, but you absolutely can, and I wanted to show you how to go about that one. Okay. Number 3 then is a little bit trickier because it's not a polynomial. So let's see. If we want to jump in and start taking the derivative here, first thing I'm going to do is rewrite this as x minus 4 to the 1/2 so that I can go ahead and take my derivative. When I take my derivative, I get 1/2 x minus 4 to the -1/2 times the derivative of what's inside, but the derivative of what's inside is just a 1. So if I rewrite this, this is 1 over 2 square root of x minus 4. Okay. Now, here we've got a fraction, and we haven't dealt with that before. So let's take a look at that for a second. When you think about a fraction, if a fraction is going to be equal to 0, 0 divided by 4 is 0, 0 divided by 7 is 0. So the key thing is that if you're setting it equal to 0, you want the numerator to be equal to 0, right? So setting equal to 0 means your numerator is equal to 0. Being undefined means that your denominator is equal to 0. So when you're working with a fraction and finding critical points, you want to set both the numerator and the denominator equal to 0 to find your x values. So in this case, I'm going to say, okay, well, I'm trying to set x equal to 0. And that just doesn't, 1, which is the numerator, equal to 0. That doesn't work. So there are no critical points by setting it equal to 0. And then we take the 2 times the square root of x minus 4 and set that equal to 0. Well, I can divide both sides by 2 to get the square root of x minus 4. And I can square both sides to get x minus 4 equals 0. And then add my x over. So I get x equals 4. Okay, so that's my critical point. Okay, now, key thing here is we want to start working with, I'm going to go first derivative test because I don't want to do second derivative test because I don't want to have to take more derivatives and negative exponents, and I don't want to mess with that. So I'm going to think first derivative test. So that we got to talk about the domain. Remember that you can't have negatives underneath the square root. So I can have 0 and anything larger than that. Well, to get 0 underneath the square root, I would start at 4. And then anything bigger than that is good to go. And I can include the 4. So my domain is from 4 to infinity. And I'm going to break up that interval at 4. Well, 4 is already an endpoint. So 4 is over here, and then we're going to go from 4 to infinity as my intervals. Okay. So my test point then is going to be something bigger than 4. So I'm going to go with 5. And we're going to test that in the first derivative. So if I plug 5 into my first derivative, and my first derivative is here. Okay. When you plug in 5, 5 minus 4 is 1. Square root of 1 is 1. 2 times 1 is 2. So you get 1/2. And 1/2 is positive. And that means my function is going to be increasing. Okay. And so really then 4 actually does end up being a local min, because while there's nothing on the left side of it, you're not going down and then coming up. You're starting at 4 and you're going up from there. So that's going to be a min. In fact, your graph looks something like this. Right? So it is a minimum point there. So we would say that that's a local min. So in that one, first derivative test is where you want to go. If you try using second derivative test, you're actually going to end up getting 0 or undefined, and that's going to end up giving you, making the second derivative test fail. So that's why we use the first derivative test here.